So today we're going to look at how to calculate combinations when there are some restrictions. So we've got several questions, but they're all based on the same information. A team of 4 students need to be made up from 5 girls and 3 boys. Okay, so the first question says, how many teams have Jess on the team? Well, how we do that is we say that Jess must be on the team. So we say there's one person, we must choose one of them. In effect, that's just one, so we don't have to even think about that. There's 7 people left, and we need to choose 3 of them to make up the rest of the team. And when we put that in a calculator, we get 35. So that's our first one. Our second one says, how many teams don't have both Chris and Emma on the team? Well, here we work out what if Chris and Emma were on the team and then minus off the total. So this putting Chris and Emma on the team works very similar to this one. So we start with the total number of teams. We minus off the ones that we have both Chris and Emma on it. So 2 people to select both of them. And then out of the 6 others, we need another 2. And that gives us 55 teams. C, how many teams have 2 boys and 2 girls? Okay, so what we need to do here is notice that we've got 2 boys and 2 girls, so we're going to have a times in there. So we need 2 boys. So out of the 3 boys, we need to choose 2 of them. And we need, out of the 5 girls, we also need to choose 2 of them. And so we multiply those together, and we find there's 30 teams. D, have at least 1 boy on them. Well, here we could have 1 boy, or 2 boys, or 3 boys. We can't have 4 boys because there aren't 4 boys. So we've got ors there. So we need to add these together. So we've got, if there was 1 boy, that would be that. But we do still need to make the rest of the team. So we need to still go, there's going to be 3 girls. So out of the 5, we need to choose 3 girls. But now, or we could have 2 boys. So 3 choose 2. But again, we've got to have the rest of the team. So we've got the 5 choose 2 girls. And finally, we could have 3 boys on the team. So 3 choose 3 times by, well, we're going to have 1 girl left. So putting that in. So that's one way of calculating it. And if we do that, we get 65. There is actually an easier way in this case. In this case, we could say, well, this is all the teams. And if we just minus off the ones that don't have 1 boy, which would in this case mean we've got all girls, that should also give us the same answer, and it does. Finally, 1 boy, 3 girls, but each person in the team has a unique role. Okay, so here we've got our normal combinations to work out how many groups of 1 boy and 3 girls we can make. So that's 3 choose 1 and 5 choose 3. But the unique roles or unique positions means we also need to order those 4 that we've selected out. So then we have 4 factorial to order them afterwards. And so then we end up with 720 possible teams with roles.